Hello students. What we're going to be doing today is taking a kind of a conceptual overview of how to use object-oriented programming in general, and then also get into how inheritance is a part of this and how important both of these concepts are in modern-day programming. I'm actually going to go ahead and skip over this section. This is mostly just something we do in class for a minute, talk with the person next to you. If you do have someone next to you, though, you might go ahead and talk with them about what construction, objects, and classes might have to do with each other. Alright, so let's move on. I want to start off with a thought exercise. It's kind of part thought exercise, part just explanation of a program. Let's say I give you these 4 classes, and notice I did not write them as actual classes. I wrote them as just kind of descriptions of it. Hopefully you can still put it together how these are the private instance variables for each one of the classes. And then they have methods. I didn't bother to really write them out, but constructor, accessor, mutator exists for each of these classes. You can pretty much just assume accessors and mutators are going to exist for all the classes I'm going to give you. And for every class you make in this class, you'll probably be making accessors and mutators. So we have these 4 classes: SchoolCourse, and then Science, English, and Math, which all extend SchoolCourse. Hopefully you've written that in your notes and you still remember that extends is how we use inheritance, meaning that all of the stuff that I'm circling here in red that exists in SchoolCourse also exists here where I'm doing these X's. So basically, this SchoolCourse is now in each of the child classes that are right here. So I'm going to start with this question: why did we make a superclass? And one of the more obvious answers to that question is just simply that so that way all of these PIVs and methods exist in all of these, because any of these courses, English, Math, or Science, all have a class name, all have a course code, all have descriptions. They describe what the class is going over. You've seen them in your course catalog. For all of them, we have to decide whether or not they're available in the school system. The state determines what classes can actually exist in that state, and then each county decides which of those courses it will support, that it will actually host, and then each school decides which ones it can actually provide. So is available is a pretty good part to include here. Included here, class type, and that would be my idea for this one. Maybe that's not the best of names, but you probably want to include a comment above it that said this is for if it's AP, if it's honors, standard, if it's any of those, to choose which one it is, to write it in there so we can have some kind of system to describe that. And then also the course code of the prerequisite course to this course itself. All of these could possibly have prerequisites. All of them could be AP, honors, or standard. All of them could be available or not available at that school. All of them have descriptions. All of them have a course code, and all of them have a name of the class. That's for Science, Math, and English. So we have a superclass because we want to be able to use that idea of code reuse. We don't want to be retyping all of that stuff and then making sure that we do have it in all the files. That just doesn't make a lot of sense. And if we needed to change one of these variables to something else or add a new one, we could just simply add it here, and it would immediately be added to the other 3. Because all of these extend from it. So that's the principle of code reuse, and that's why we make superclasses. Now I want to go a little further though and explain a question I didn't write here, but why did we make subclasses? Why did we make these three? And that's ES at the end of classes, subclasses. Why did we make these other three? Why not just use SchoolCourse? The reason I'm hoping is starting to appear to you is because each of these courses then have special things that really only apply to them. While math and English classes all have different levels, English 1, 2, 3, 4, AP Lang, AP Lit, and math, of course, having its Algebra 1, Algebra 2, Geometry 1, Geometry 2, so on and so forth. Science, while it would have different levels of, biology and then biology AP, we don't notice that as much happening. We don't usually have biology 1, 2, 3, 4, or, anything like that. So I didn't want to really include level over here. I didn't see it as being a necessity. What I did see as necessary to include there was branch. It seems that for the largest part in our school system here, we divide science instead of up into levels, we divide it more into subjects or branches of science, of biology, of physics, of psychology, of all of these. Yeah, and then meanwhile, we would give something very specific to math over here for Euclidean only, boolean variable. We just simply say whether or not this class is only Euclidean geometry or if it includes other sorts of math that do exist, but we really just don't go into here. And then English, of course, would probably have books to read. More likely than not, while you might read some things in these two classes, a majority of your reading is happening up here. So I'm including this private instance variable because that's an important thing to specify, is how much reading you have to do in an English course. So the subclasses were made. Why? Because they each had special features that set them apart from the others. Even though they all pull from all this stuff and therefore are majority the same, the majority of these classes are very similar to because they all have these same 6 private instance variables. Meanwhile, each one only has 1 or 2 unique ones. But those 1 or 2 unique ones make them unique enough that it would justify making different courses. So, how could these classes be used? This is actually more the fun part, because this is more the thought exercise part of it. Really think about it. How could these classes be used? I would suggest taking a few moments to just go ahead and maybe pause and think about it, and then go ahead and play when you have hit play again on this video when you have a good idea. Alright, so maybe you came up with the same idea, maybe you came up with a different one. My idea came from this. Just simply as a teacher and a programmer, I've been doing a lot of educational software building. Students in my class have seen Schlecker's practice environment or the Schlecker's principles practice environment, and hopefully my digital IT class will be seeing another program soon that should help them in their class with the reference exerciser thing. So the first thing I thought about was how I could use something like this in education. Taking it like this, it's actually making a very easy category system that could be used perhaps with student data. If we made another class called student, let's go ahead and actually I'm going to go and bring up a notepad document for this because it's going to be a lot easier to read. So let's say we had this one, public class student, and this student, of course, has name. We'll divvy it up a little bit. First, last, middle. You must have age, grade, and I'm actually going to go and put those on one line just to make it a little easier. And then I'm also going to remember to actually write in data types because I don't know why I forgot that. All right, there we go. That's good. Alright, so when we make a student, we're going to go ahead and give it more than just name, the full name, and the age and grade, but let's also include now school courses, because the student should have courses. Now, we're going to assume this is a high school student, so this student should have about 7 courses, and we'll just go and put here for schedule. Notice how that is a school course array. So then when we go to make a student, public student, this is our constructor. And I seem to be having some trouble capitalizing things correctly. Constructor should take a few things. Yeah, there's going to be a lot of stuff. And the most important one for this example would be this array of school courses. So we're assuming that this, and actually I'm going to do that a little differently. No, actually, that might be the best way to do it. Alright, so this student is going to have 7 school courses, so we can assume that this S here has a length of 7. I'm going to go ahead and save it in there. And assume that I'm doing that for the others. Alright, now, if we notice here then, we are now passing an array of school courses. Assume there are 7 courses. And we're passing it to this student, so that way this student has 7 different courses. Now the really special part here is that this array can hold multiple kinds of school course, because science, math, and English are all considered to be school courses. That is that, if you remember, hopefully, that is that concept of polymorphism. Poly, many, morph, shapes or forms. Polymorphism in that right now science, math, and English are all school courses in addition to being the classes they are. So that means that schedule right now can hold 7 different kinds of school courses, plus some electives that I didn't write here, or the 4th core class, history, that I also did not write here. So then from that, I can then go on even further, and perhaps in another file, I can go ahead and have a public class school runner. And this class then can be where we do everything. That's where we can go ahead and make various school courses. And we'll just go and put them ENG1, ENG2, ENG3. We'll just focus on English for now. And that would take in, of course, 2 integers and then all this stuff. So just going to put that comment in there. Then there's some arguments in there. And pretend I'm doing it for the other 2 English classes there. Then I can go ahead and make a whole bunch of students. That's student population, and that one can have, 1,000 students inside of it. My high school only had like 600 something, so 1,000's not too bad. And we can go on even further from there. So how can these classes be used? My idea was to go ahead and build a school simulator, one where you had students with all these different classes, and these classes here are used by having them be kind of like held as private instance variables by all the students. So notice how student and course and each of the specific courses are all objects. They're all defined as being their own thing. you might pause the video, and if you're starting to have some, a religious experience of some sort, you might go ahead and pause the video and finish having that aha moment, and then we shall we're back here to this number of definitions. Hopefully you remember this from the last lecture. Hopefully you also have all 4 of these written down in your notes. If you don't, I'm not sure why you don't, but go ahead and put them in now. So the superclass, also called parent class, is the class that is inherited from. Subclass is the class which inherits from the parent. Extends is the code that we use to do this in Java, which is the language of this course. And polymorphism, the state of being multiple classes at once. Write these down in my words, write them down in your own words, write them down in whatever online resources words, write them down from our textbooks words. Have these words defined in some way for you. I have also included a Quizlet for it if you feel like you would learn better from that. I wholeheartedly endorse using things like Quizlet and Memrise and all those things to learn words. So we're going to go and move on. I want to go and wrap this up. I'll go into some of the assignments that we're doing next, but here are the final remarks. Actually, I'll go into some of the assignments we're doing in the next video. That'll just be included with this in a little playlist. So final remarks. Smart object-oriented programming, which is putting each section of code, sectioning off your pieces of code so that way they are in these categories, in these objects, is helpful for, one, I put collaboration here. Because if you're working with someone else on a project, it should be easier for them to use your code. They shouldn't have to be retyping things or coming up or being confused as to what pieces of code can actually be used in what ways. Collaboration is helped by having objects for both to use. Having objects for both programmers to use. Or all, I should say. All. It's helpful for code reuse, which is where we're able to take the code we've already written and reuse it without retyping it at all, just by calling it. It's helpful for software development because it helps you envision your final product in a much better way than if you just procedurally coded everything. And lastly, it's good for maintenance. You might have this experience if you really do take on programming as a hobby or as a career. For myself as a hobby, I've come back to older programs that I've been working on, and it made the process of coming back to it and fixing it up a lot easier because I put it into all those objects. Because then I knew if there's a problem with this or that part of the program, I knew exactly what file held the contents of that object. So please, be smart with your coding, because it's going to help you collaborate with others, have a much quicker and more intuitive programming session. It's going to help you envision your final product, and it'll help you with fixing up your code and correcting problems. All right, that's about it for this lecture. Thank you for tuning in. If you need to see the assignments for this, they are linked below. Thank you very much, and have a good one.